Recording. Tamid, over to you.
Thank you, John Bhai. Let me just share my screen and I'll just start then. Can you see my screen?
Yes.
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 Okay. So hello and welcome everyone. I'm Tamit, as Jawad already introduced me. And today I will be taking this presentation on effective context management. So we'll see how we go from noise to clarity. So for today's agenda, we'll go through what is context, why context management actually matters, how LLMs handle context, how IDEs like cursor actually manages the context within itself, and finally, we will see some best practices for effective context management. So for today's presentation, we will mostly focus on context management in cursor. In Cephala, I think most majority of us are actually using cursor as the preferred AI IDs. So we are actually focusing cursor for today's presentation. So just before we start our presentation, just one key takeaway is like treat AI like your smart teammate with short-term memory. The clearer and more focused you keep their attention, the faster and cheaper they will deliver great work, the work that we actually want them to do. Okay, so before starting, let's just first go to the definition, like what is actually context? In simple terms, it's actually information we provide to an AI model so that it can actually understand our request and respond accurately. For like human analogy, like think of you are giving a coding problem or a Jira issue to your colleague. If your issue is like has like too little information, then your colleague, they won't actually understand what's the problem about or what to actually do about it. They will be confused. If you give too much description, then it will be difficult for them to actually figure out like what are actually wanting. Maybe there are like too much irrelevant information, it will actually divert their attention. But if you give them enough, then they will solve it quickly and correctly. AI works the same way. It thrives when the context is clear, focused, and relevant. So what does the context actually includes in AI, in IDEs? Like in Cursor, the context can include the current file or the code block or the area that you are currently focusing on in the in your editor, in your AI editor. It can also include other open files or reference files. It will include system and the user prompts, recent conversation history in your chat list. It can also include the hidden system metadata, like for example, your OS version, timestamp, your location, things like that. It doesn't really, as far as I see, it doesn't actually include location, but it actually includes your OS information. List of available tools, so the LLMs can know like which tools are available to get more information from your environment. It also contains tool calls and results, and also like for IDs like Cursor, when you actually make a query, it actually tries to get some results or some code segments or context segment from your code base based on semantic analysis, and also include them in the context. So when you ask a question or run an AI action, like maybe agentic actions, all of these actually combines as the context, and then it gets sent to the LLM. So this is just how it actually works. Like like when we are actually doing an interaction, the LLM through Cursor or through any other vendor, we put a message and we get text as a response. And each turn or each interaction that we do is actually stateless. What does it mean by stateless? It means that when let's say we're in turn two, when we send a message, it doesn't actually have information of what interaction that we had in the previous turn, right? So to put the previous turn in the context, we actually need to put both our message and the text response, prepend it, and send as a new input. So every time, so more interaction you will have, more input size will get lengthened. And this is how it actually looks like. When you have turn three, you have a bunch of user messages and text response in the input. And this also is true for extended thinking and tools as well. They also count and become the part of the context as well. So If you are using extended thinking for a model, maybe you need it, maybe you don't need it, but in the end, they actually get part, or they actually get added as in the context window. And when you're, and like, for example, like when you're doing, let's say in your turn one, you turned on extended thinking. In your first turn, it actually gets added as the output, but in second turn, it will get added as the input, including the result of the tool. And it kind of goes on, so on. So now we see like how context actually gets lent with more interaction that we have with the LLM. So we need to like understand, like now we must need to consider like how we can actually manage the context and why it actually matters. As we've seen, like more interaction we're having with the LLM, the context window is getting longer and it's going to increase cost. LLMs, they are actually built per token. You can also see that with cursor as well. So more token, that means more cost. If you have unnecessary context, then it will just waste your money. For analogy, think of like logging everything in debugging production. You might not need it in debugging production. You maybe want to have like one or error logs because that actually helps you to find the issue. Same thing goes for LM. You have unnecessary context, it will just waste your money. It also affects speed as well because larger context means it will take more processing power and it will give you slow responses. For analogy, you can think of like you have that one file where you actually want to do some editing, but you're actually loading the whole project. Maybe in some cases it's good for if it's relevant to the context, but if it's not, if it's just a separate file, maybe it's just better to open that file instead. Another point is the relevance. So more context doesn't necessarily mean better result. I mean, if the context is relevant, then that's okay. But if it's not relevant, you have one question, then you ask another question which is not relevant to the first one, then it can also confuse the model because the LLM, it will see as a context from your first question to your second one, but they might not be related. So this can actually confuse the model. It's almost like, like you ask your teammate where's the API bug, but you give them the whole code base, not the actual file that actually that can actually contain the bug. So they need to go through, everything. And in most of the cases, they might see that, okay, the bug was maybe on just one file. You could have just sent me just one file, right? And the last point is like the consistency. So if you give proper context, the AI will be aligned with the task and uh, they will actually do the task properly as well. If it's not consistent, AI, how they work with probability, they might take a different path and it might be inconsistent with the actual question that you asked. So for analogy, you can think of like keeping your teammate on the same feature branch. You don't give them another branch and tell them to fix on there where the issue might not be present. So now we see like why context management is important, how these LLMs actually handle this context. To understand how LLMs handle this context, we need to understand these three key concepts. One is the context window, second is the tokenization, and third is the compaction or truncation. So context window. A context window basically means the maximum memory or the maximum length of the request the model can process when you're actually making the request. So some models, it can process 128,000 tokens, some like million tokens, depends on the model. And as I mentioned that the LLMs, I mean, each request you make to LLM is stateless. And the input and output both actually contribute to this context window. And if it's more than the context window, then it might actually give you an error. What's the tokenization? So when LLMs don't actually process on words, they actually convert it to tokens and then process on that. For different LLMs, the tokenization is different, but usually we see that if you have like 100, we see that if you have 100 words, then it will be converted to around like 120 or 130 tokens. So 75 of so the token length actually becomes like, if you have like 100 words, then the tokens will become 125. So there will be like more tokens. So I think in general, it's like 25 increase of the tokens. So you can also keep that in mind. And the last point is a truncation or compaction. So basically, we'll see in a demo as well. So if the input exceeds the context window, then the model or the agent or like the IDE, they actually drop the older or relevant context or summarizes it or compacts it so that it actually can fall in the context window. Because if it goes out of the context window, then the LLM won't be able to process it. So think for human analogy, you can think of like uh, chatting with a friend in a noisy cafe. So your friend is telling you some things, but you can only remember the last few things they say. But if the story goes on forever and you have like tangents and flashback, you'll forget how it even started, right? So LLMs, they actually work in the same way. Once its mental whiteboard or the context window is full, it has to erase or summarize the older nodes to make room for the newer ones. So this context or the request that we are sending is actually, it's finite, it's not infinite. So let's see a visualization here. So for this visualization, yes. So for this visualization, we think we are considering is just a simulation that I created. So for this simulation, we'll think that this LLM only supports 8,000 tokens as its context window. And if I start it, you can see that there's some interaction going on between the user and the LLM. And the LLM might ask for some tool call, and everything they actually get added to the context window. And when we see that total tokens are approaching the context window, the LLM or the provider, they will actually summarize it or compact it so that it always falls under the context limit. So in above, you can see the context used, like when it's actually approaching 8,000, it's getting summarized. You can see the total tokens, which is actually the summation of all the tokens in iteration. You can see the iteration cost and the total cost, which is actually the summation of all cost, summation of cost in all iteration. So more iteration you will have, more costly it will be. So you need to realize, like when your model is actually, or when your response is actually deviating from the question you asked, and decide on whether you want to continue the iteration or start a new iteration with more compact or summarized question. Okay. So the next part is like context management IDs. So how does IDs actually manage this context? For Cursor and also for like most of the IDs, they automatically includes all the open files, imports, and recent edits. So for example, maybe you edited some file, you might not have committed it, but you also have closed it. Those information are already in Cursor's memory. And whenever you're making any query, those gets added to the context. You also have the power to manually control your context as well. Like you can manually control which context you want to be sent with at file name or hash symbol, or by copying some segment of the file and send it to the LLM. Also for smart IDs like Cursor, based on your query, it will add some relevant file or file segments to the context. Cursor basically does remote indexing to your whole code base and stores it in its database. So when you add a query or when you ask a query agentic word, based on your query, it will actually try to search relevant segments there and add it as a context. So basically every agent asks or plan sends a context snapshot to the model or the LLM itself. So based on, so in Cursor, you have like 5 different modes. And based on these 5 different modes, the context size actually matters. So the first one is the tab edit, which is done for like small edit or refactor in the current file. Sometimes can be done in multiple files as well, because whenever you are making an edit or when you're actually opening a file or scrolling up and down, Cursor actually remembers that and does some indexing to that to those files, I think both locally and remote index as well. And he keeps that in memory. So when you're making an edit, if that edit is relevant to those files, Cursor will suggest you that, and you can just do it with tab. And the cost is very low. It's actually zero, the tab edit, because it actually works with very small context. The next mode is inline chat edit. This is it has a bit more context than the tab edit. We will also see this in the demo. And we can basically select some part of the code and ask question or small edit into that segment. The third one is the ask. So basically we can, this is used for broader repair query, like if you want to have an overview of the project architect, or maybe some if you want to do some refactor, maybe you want to know like where this method is being called throughout the project. For those kind of information, like query type of information, we can use ask. Plan and agentic work, they actually work a bit together. So plan is basically used for to generate a plan for refactoring or maybe for a feature addition. An agent, it actually works based on a plan. Sometimes if you don't generate a plan and just go with agent work, the agent can in the background generate a plan and work on that. We'll see this on the demo as well. Okay, so just before going to the demo, just want to talk about some practices for effective context management. So the first point is always be intentional with your context, only add the relevant files. And if only add the relevant files, and also like if you want to selectively add some files, use add file name or hash symbol. Hash symbol basically gives you the list of files that you have edited or viewed. And also keep the unrelated files and close the, I think I just wrote it mistake, but you should actually close unrelated files or tab for some big refactor requests or some questions. They can also get added to the context as well, because cursor is really smart. It actually, when you're asking a question, it will also add the files that you have opened or the files you have actually made some change on. So for analogy, you can think of when you're asking for help, you won't hand over the entire project file folder, right? You will just say that, okay, this is the file I'm having issue with. Can you help me here? So this analogy, I mean, all this, the best practices and the analogy, they are kind of like related to our daily practices that we do. The second point is keep your prompts goal oriented. Start with what you want before the details. Like an example that I actually want to refactor the login logic to reduce duplication. So that's my goal. Where I want to do it, to auth service and login controller. When you mention it like this, then Cursor will only include auth service and login controller and the relevant files to the context. It won't add additional files. If you didn't mention focus auth service and login controller, it might introduce more files to the context, which would have like increased your context with irrelevant details. So for an analogy, you can think of like when we are delegating a task or when we are creating a Jira issue, we basically say what's the goal and the scope of the task that to do, not the history of it. Sometimes we add the history, but not like the full history, maybe in very briefs, because our main goal is to like have the task done, and for that we just need to know what to do. The third point is managing files and repo size. So basically, if you have large repos, I mean, as Cursor, it indexes your whole code base and keeps it remotely. And when you make a query, it does semantic analysis to get those relevant files. So if you have large repos, it could be like more files in the context. So if you know that, okay, some of the files, they don't need to be part of Cursor indexing, you can just add them to Cursor ignore or even in Cursor rules. Also, like another point is like you can also maintain summary files like agents.md, where you actually give a brief example of what to include, what not to include, or what to exclude, and some best practices that you are following for that particular project. So for analogy, you can think of like when we are actually having a new member, we don't actually walk through them to every class, right? We just give them a project overview, and based on project overview, they actually have like better understanding for that. The fourth one is like summarize and reuse context. So it's better to create summary files as MD file or markdown files and use the summary as context. Rather than giving raw files, it's better to give summary files, and Cursor and these IDEs, the LLMs, they figure out like what to actually include in the context based on your query. For analogy, it's like briefing a new teammate with concise note instead of every commit history. The fifth, and to me is one of the most important points, is that we should reset context when needed. If we see that the response is starting to drift, restart or clear the chat and reintroduce the problem consciously. Also, if you are asking a question which is not relevant to your previous question, it's always better to start with a new chat. It will keep the agent or the LLMs more focused on that particular problem, and it will not include unnecessary context from the other questions, from the previous questions. So for analogy, it's like simple, like when a conversation goes off topic, we pause and restate the main point so that we can keep the attention focused to that particular point. Another point is like if as we are more used to agentic work, so before jumping to agentic work, it's always better to make a plan first. Uh, it's recommended to plan with a slower premium agent, but if your plan or if your the work you're trying to do is not really that complex, you can also do it with a fast agent. A clear plan actually helps you to reduce unnecessary edits or file modification. Like if you just jump into agent mode, it might do unnecessary edits, and you will tell him to say that, okay, this was unnecessary, revert it. So there will be more tool calls involved, more context involved, and it will cost more. So it's better to have a plan first, then have like some kind of a fast agent to work on that. Fast, cheaper agent to work on that. So it will reduce your cost, and also it will make your iteration a lot faster. So it's almost like, a senior engineer for our like analogy, like in our practice that we do, like a senior engineer or tech lead, they actually creates the design or the task breakdown, and junior developers, they actually start to code based on that design. The seventh one is chunking large tasks to smaller ones. I think it's pretty basic, like how engineers we break big tasks into small manageable tasks and work on them iteratively and then merge them. For AI, it's also the same thing. It's better like if you have a big context, or you want to do a very big changes, it's better to create small tasks, small variable steps from them, and execute them separately and iteratively. The 8 point is also like almost basic. Like if when we are debugging a single or failing test, it's better to only include that state trace, not the whole logs. Like you can think of like how we actually do debugging, right? In the production, we only check for error logs. We don't actually see most of the time we don't actually see whole logs. We only try to see some patterns, so the error message that actually failing the test. So give that information uh, to the LLM, and it can keep their attention mainly on that particular part. Okay, so now we talked about some best practices. So I will just give some demo about some practices, and also like when to use what modes. So as I mentioned that in Cursor, we basically have 5 modes. The first one is a tab mode. So if you want to create some small methods or small refactor, we can just use the tab one. So for example, I want to say that it already is giving a solution because I actually did some dry run before this demo. So let's say I want to actually create a private method to get request query params this time. So if I just put tab here, it gives me this auto-generated method. So this type of for this kind of small stuffs or small code generation, we can just use tab mode, and it's almost like free. So it doesn't cost us anything. The second part which I talked about is like the inline edit or inline chat. So for example, let's say there is for this code segment, maybe I don't know what is actually doing, and I want to know what is actually doing here. So I can just select it, use Command Shift K on Mac, and select the model. I use Haiku because it's faster and a bit cheaper as well. I'll say quick question and say explain this code. So it gives me some information about this code. Now, I just want to show you one thing here. Just if I, okay. So if I go to my Cursor pricing page and just refresh it, so I just made one call with Cloud for 4.5 Haiku for inline edit, and you can see the number of tokens to it, which is 4.5, which is 4.5 thousands, and the cost is very minimal. And the tab I did, there is no cost for that tab. Now, if I do the same thing, I want to know about the same method again. Let me just close it. But I want to actually know it from chat. So let me just open a chat. And here I want to say explain the code. Same thing. I will use same model. Let's see what it says. Okay, so yes, almost same explanation, just a bit different format. But let's see how much cost it took me. So it used almost 5 times more tokens here. Most of the times it looks like 3 or 4 times, but this time it took 5 times more token, and it's as Haiku is cheaper, so the cost difference is still minimal, but you can see the token count. It's a lot. So if you have like if you want to have explanation for small code segment, you can do inline chat, which will be a lot faster as it takes less context. For Ask, as it's mainly used for like project specific stuff, so it takes more. Okay, sorry, I think I used agent one. I can just use the Ask one and say it again. So same, okay. So I did the Ask one now. So let's see what it says. Okay, it still took like almost 17.4 thousand tokens. So when we are actually want to just Ask is actually used for project-based queries. So if you want to know some architecture or maybe some between the classes, it's better to use Ask. If you just want to know some query about the file itself, it's better to use inline chat. So different type of modes was created by Cursor for different reasons. So if we use it accordingly, then we can actually reduce cost and also to keep the context minimal. Okay, so I also did the same thing for agentic as well, though I shouldn't actually use this for agent because I just want code explanation, not some agentic word. But you can see like I can actually do it with agent and plan as well, but it will cost me like more token. So it's better to do it's better to use these modes accordingly, like based on the task or based on the requirement that we have. Okay, so now I just want to do with another thing. So I want to give you an example about agentic work. So let's say I have this particular class performance controller and I want to add Swagger documentation here. So let's give this a task. I want to do it plan mode, and I will say add Swagger annotation and documentation on performance controller. Let's see what it does. So it's planning, it's checking. As I mentioned, also like when it's planning, let's check some other stuffs as well. So as I mentioned that we should have some agents.md file. So Cursor and some other IDEs, I know that Google Copilot as well, they actually parse this file and they actually add this to every context. So whenever you're making a request, whether this is a query or inline chat planning or agentic work, to your every request, this context will be added. And the LLM will follow this particular context or this particular information and work accordingly. In Cursor, there are some Cursor specific rules as well that you can add. For example, I have this controller pattern rule that I want this to be added to all the files that have this particular pattern. So it should not always apply. It should only apply when it matches this certain file type. I have some other file types as well. Like if I want to apply this to all the files, then I can use this particular template or this particular information. And there are some, and I also provided the link where you can actually have more templates specific to cursors. But if you're using some other ID, you might want to experiment with those. But for cursor, it supports both agents file and the MDC file. So agents is a bit more generic. Here you can just give them information about where you have the docs. Like for example, I have docs in the docs directory. I have load testing guides in this format. And I also have like the commit message format is also defined on this particular document. And the LLM will read this and actually try to follow that pattern. Okay. So now back to the planning mode. So it says that if it wants more information, like what should be the tag name, or should it have responses on? If I went with agentic mode, then it would have just added those things by itself. And maybe in the end, I wouldn't want it. I would have wanted a different thing. So it could have been like more iterative work and waste of tokens. Okay, so I will just say yes, only add tag, add operation, annotation, and API responses. So I think this should be enough for the LLM to understand what to do, and it's now creating a comprehensive plan based on that. So as I was in planning mode, I was able to iterate on it. And as developers, we don't actually plan from the first. We just update our plannings and be agile and do things on the fly. So sometimes in the planning, I mean, you could say that, okay, I could have just add all this information for that. But when I see the plan, I get more information on my mind or more stuff that I actually want to add later. So now I see this plan, and for now, I'm satisfied with it. Now I can just say generate it with a more simpler model or cost efficient model. As the plan is there, I think as the plan is there, then this type of model can actually do agentic work agentic work easily. It doesn't need to think much. So I can just say build, and it will just add those annotations or whatever I ask, the annotations and the text accordingly. So I can see that they are actually adding it. Yeah. So when they're adding it, I can just also refresh my page and see the actual cost. So I used planning. I did planning and did 2 iterations with Claude 4 and Sonnet, and you can see the cost there. So if I did agentic work, it would have taken more tokens because there would have been more tool costs and such, and it would have taken more cost. And the Haiku, you can see the agentic what is doing. It already took 170,000 tokens. It's as it is working, it's going to take more. But as Haiku is like almost 5 times less, I think five or 3 times less expensive than Sonnet. And even if it makes a mistake, I can just interrupt it and provide the right direction for it. And this kind of models like Haiku is very, very fast because it doesn't do thinking. So even if you interrupted it or if you reiterate on it, it won't cost you that much. Okay, so yes, that's basically the practices that I wanted to show in this demo. And I think the rest of the points that I mentioned is like pretty basic. And I think most of us actually follow it on a daily basis. But to actually feel it, I want to show you another different thing. So how I wanted to actually show you now, what are the contexts that actually cursor is sending. So for that, I just want to use a proxy. So if I go to model, I'll do API keys and I'll just enable this open API key. So what it will do now, like when I'm going to make a request to LLM, it will actually send it to this particular request. And this is actually a third-party site where I can actually see my request and response just to get the feel of it. So let's start again from the beginning. So let's say I want to actually know about these methods. So if I say again, Control Command K, this time I will use a custom fake model. And I will say, explain the code. I will say quick question. Let's see what it's go with. Okay. I think I should be able to see it here. Yes, you can see the time here. I actually already gotten this information. So for easier visibility, I'm just going to copy it to this different site. So you can see here what kind of prompt that cursor is using. For inline chat, it's just using this particular prompt, like system prompt, you're an intelligent programmer, Kohli is writing a code, some things like that, and what to do actually here. And in the user, you can actually see some of the information. It actually has information about the code segment that I'm trying to update. I think it's this part, the selection part. You can see with the selection tag. And it has also information. It is also adding more context, like what was the code parts before my selection and after my selection, so that the LLM can work better. And it also provided the question. It also have some like additional context here as well. Okay, so now let's see the same thing, what in inline chat mode. So if I just copy this again, I'll use a new chat because it's not relevant to my Swagger documentation. I'll just use ask. Ask agent and plan is like almost similar, just have different tools. So I will just use custom fake. Okay, so it already sent the response here. Let me just grab it, copy. And if I just paste it here, you can see the system prompt is quite different. It's saying that you are an AI agent, and the prompt is much more longer. In user, uh, in the user role, you can also see that it has information about my OS as well, the current date and things like that. It also contains the information about what are my new files, what are the things that I have edited and not staged for commit, things like that, and also my file structure as well. You can see that application test.yml, build status.md, build.yml, things like that. And then also based on the question that I asked, Cursor also grabbed some relevant context and also added there as well. And as I did some asking, so LLMs will try to derive an answer from this particular context, but if it's not able to do it, then it will use this kind of available tools to get more information from my environment. So you can see that one of the tools is code-based search. If I go to the last one, I think it will be like, okay, global file search and things like that. List directory. So as I'm in asking mode, it's not going to expose any kind of agentic tools. I can also show you an agentic tool example as well. So let's say I use agent here and just use the same one. Okay, so if I go here, so again, same derivative work, copy, just to show you. Okay, so now it has, I think, more tools now. Some of the tools, it will contain things, web search or things like that. I hope it won't. You can see that there's a new tool, edit file. So this is not actually available on ask or plan mode. It's only available in agentic mode. So based on your cursor mode, it might add more tools. More tools means more context. And the LLM, it will say that, oh, you asked it for agent mode. So it might even try to do some editing, even if it's not intended. So you need to actually understand which mode to use when. And it's pretty simple, actually. So yeah, you can see more like edit type of modes, and the context, it's almost like similar. And there could be some simple differences here. Like it will say that, okay, as I am doing it agented mode, so you're allowed to do some changes here. But rest of the stuff, it's pretty basic. And when you're going to have more chat, if you're going to have more chats, you will see that this will actually increase these messages. For more, as your interaction increases, this elimination messages will increase as well. So yes, I hope this can actually give you the feel of like how context and the different modes actually work within Cursor. And for other IDs, it will also have like work in almost similar ways as well. Okay, so we are almost at the end of our presentation. So for summary, we see that context is memory. If you provide too much or too little, it might hurt performance, or you might not get what you're intended. Token is money. More tokens, that means more cost. Clarity beats quantity. Your prompt should be clear about what you want, what you want to do. It can be big, but it needs to be clear, and it needs to be based on what you're trying to achieve. And use IDE features to include context. For example, add file or part of files, use ignore rules to include files that you don't want to be part of the context, and also like do some context inspection as well. Like I show you one example of doing that with webhooks. It's better to use LLM gateways, then you can actually see the request and response, but I actually didn't get time to actually set those things, set it up. But I think that would have given a bit more better clarity on that. And the final part is that good context management actually becomes habit over time. It's not going to be based from the word go. So you need to actually iterate and refine. And based on your project, maybe a different set of rules could be like applicable. So it's something that we need to actually build a habit on and don't get like frustrated with it. Like continue with it. And yes, so that's basically it for the presentation. So does anyone have any question or any feedback? Please feel free.
Hello. Bhai, can you hear me?
Yes, I can hear you,
Uh,
Shumanto.
I have one question. I have a habit of switching between tabs. I mean, the chat tabs. So if I suppose when saw that the response is not that much good, so I just create a new tab and continue chatting again. So is that costing me more token, or is this a very good habit or something? I mean, I just want to know when to go for new chat or when to use the
I
existing
mean,
chat.
yes, I mean, if you're in your existing chat and you're not getting the response that you deserve, then that means that your context or the information you're providing is not actually good enough, or is actually making the LLM be aligned with what you want. So it's better to go in a different, it's better to try a different way, basically. So the new chat, I think it's the good, better way to go.
Oh, okay. Thank you. But so it will cost me more token if I go to new chat.
No, because when you actually go to a new chat, then you're starting from the start. So it's not going to include the tokens from your previous conversation.
Okay. Okay. Thank
And
you.
even and the it will add the system prompts in most of the cases will be cached as well. So it will cost you 10 times less. But it's always better to go with the new chat.
Okay. Thank you,
Hmm.
bye.
Okay. I can see Rashik raised his hand. Maybe you can go.
Hi, Tamid. Can you hear me?
Yes, I can hear you.
Okay, first of all, great presentation. So I just wanted to know that you showed the planning phase using Cursor. So do you have any suggestion? I mean, for GitHub Copilot, we do not have that planning phase. But what I understand that if you make a plan and then give your LLM that plan to actually execute what you want to do, it will cost less and give me better answer. So do you have any suggestion how to kind of mimic that in Copilot?
Yes, I think in Copilot you can maybe start with ask, or I mean the LLMs are also like quite intelligent. You can also start with agent, but maybe you can just start with ask, and you just can ask Copilot to make a plan for it and put it in like a markdown format, and then use another chat with a different model or maybe the same model, and use the newly created MD file as context. So your MD file, when you are asking it to create a plan, it will actually act as the plan. I hope
Got
that
it.
answers
Thanks.
it.
Yes, thank you.
Okay, I can see more people are asking questions. Yes, Mitten Joy, you have raised, I can see your hand raised here.
Yeah, so have you used the compressed command from Cursor? So it actually summarizes the
Yes.
context that we have. So, and I know that they apparently compress itself after some time. So, is it good to use compress of our own or wait for the Cursor to compress itself?
Basically, I will say to go for the second option, like cursor to compress it itself. Because I mean, if your context is relevant, I mean, if you're continuing the chat and your context is increasing, then I will assume that your context is relevant. So have cursor summarize for it. But if in Cursor, as we see that we have limited amount of users, like $20. So if we see that it's actually increasing the cost and we have a lot of context, maybe with a premium model like Claude 4.5 Sonnet or even in thinking mode. So maybe we can think about summarizing it ourselves as well. It actually depends on the situation. But in generally, it's better to rely on the IDE. I mean, it's in my opinion, basically, because I think the IDEs or the way the Cursor, they are actually improving their product. They are quite intelligent. So I would I would actually try to trust that. But if after some iteration I still see that it's not giving me a good result, then I might summarize it and also have those summarizers in an MD file. Then I can review it and make some adjustment and start a new chat with that summarized file. I hope that answered your question.
Thank you.
All right. I think it was a great session. Anybody else has any question?
I have a one small question. That is, Cursor does have a automatic switching model. So, can you distinguish a little bit when we can use that one, and what is the benefit or disadvantage regarding that?
Sorry, I didn't get it. Which can you say it again? The which feature that you are describing?
Auto switching, auto model, যেটা,
Oh,
which
yes,
one?
yes, yes. Auto model. Personally, I don't prefer the auto model. It's my personal preference because in auto model, I can't actually see which model they are using. Though in the documentation, they're saying that they are actually using a premium. They will use a premium model and they will switch to different premium models based on the availability of the model or the latency of the model. But they can also use other models as well. So maybe I asked a complex question and they could be using custom small for that Cursor small model for that, and because that's available there. So for me, I don't actually like to use something that I don't know what's going on. But if it's a simple thing, then you can use auto. Cursor says that they are actually invested a lot in the auto model. In my experience, I not all not most of the times I actually didn't get good results from the auto model. So I like to use models that I am seeing basically. So for me, I mean, for complex stuff, I prefer to use, it's my personal preference again. I like to use Claude 4.5 Sonnet or even thinking mode if it's more complex. For smaller stuffs, I would like to use like Haiku or um, Haiku or even Grow Code 1 fast, which is also pretty fast and pretty good for compared to its price, and sometimes Composer as well. I hope that answered your question.
Hello, Tahmid Bhai. I have a question.
Yeah, sure.
First of all, thank you for your nice presentation. I really enjoy it. So as per I have seen, like as you just showed in the presentation, that a small model like Heiko is actually performing better with the plan we are providing. So as you have already gone through a number of things with like this model things, so I'm wondering, like, should we actually prefer uh, a big model or like a better model for generating the plan, and then go for a bit smaller model like Haiku 4.5 for the agentic work? Or should it be like, if it's a very good, very intense work, should it be like first go for a better model for planning and also do the same agentic work with that model? Yeah.
I mean, it actually depends, basically. I mean, as I mentioned, like if you are actually trying to solve a very complex problem, then it's better to use a premium model like Sonnet 4.5 or other relevant model for that, and use uh, faster or cheaper model to do the agentic work. If it's not that complicated, you can use the same model. But main thing is like if you have, I think if you are using Copilot, I think Copilot currently at the moment doesn't have much limitations like Cursor in terms of uses. So there you can also go with 4.5 Sonnet in every way. I mean, if there is no, if your hands are not like tight with cost or any kind of limitation, why not use the base model for everything, right?
Nice. Thank you.
So it's actually about mainly like trade-offs, like what are available to you and what you can actually do with the available tools you have with the limitations.
Yes. Thanks.
I think we have a couple more minutes left before the session time ends. So any further questions? Okay, I think that's it for today. No more further questions from anybody else. Ahmed, thank you once again for the great session, and thank you everybody else for making it such an engaging and fruitful session. Thank you, everyone. Thank you very much. Have a great rest of the day.
Thank you.
Have a great day.
Bye.
All right, bye-bye. Take care, everyone. Yeah.